Hello, welcome everyone. We can start by giving you an overview what was going on since the last time we met. Gonna paste the link to an issue for everyone to see. Okay, so I've pasted in the chat a link to an issue where we are announcing that we have freezed the toolkit releases for now. What we are doing is we are making, yet again, breaking changes to the API. And we are working towards the first 0.1 release. And this release means that we'll be promoting the current APIs from V1 Alpha 1 to V1 Beta 1, and the Helm release API from V2 Alpha 1 to V2 Beta 1. So it's not a V1 release. That means we can still do breaking changes in the future. What it means that we have, let's say, sorted out most of the features that we want to keep from this moment on. So for the current features, we expect that the current API will be stable. We made some breaking changes regarding dependencies. I'm going to explain a little what we did there. So currently, when you say, hey, I want to make sure Istio has been installed and is running before I'm deploying my app, for obvious reasons, because the injection webhook has to be there for your app to have a sidecar. So that kind of dependency, when you would declare it with customization objects, those two objects have to be in the same namespace. So the customization definition for Istio and the customization definition for your app has to be in the same namespace for you to be able to define this kind of relationship between the two. And let's say for customizations was okay, because if you think about that Git repositories and customizations are only created by cluster admins, they can use the namespace where the toolkit is installed and declare there all these objects and relationships between them. But this doesn't quite work for Helm releases, because Helm releases, well, those are like Kubernetes deployment. So you want a Helm release definition to be in some app repo or some team repo. And the problem is, let's say you have two teams that are sharing the same cluster. The cluster admins will install Istio because they have the right to create resources, cluster-wide resources that are coming with CRDs, injection webhook, and so on. Then your teams, they will be creating these Helm releases in their own namespace, and they will want to say, hey, I want my app to be this Helm release. I want to be installed after the Istio Helm release or the Linkerd Helm release or whatever else. But maybe that release is not in the same namespace. And for sure, it will not be in the same namespace if we are talking about service meshes, because a team cannot have its own service mesh. It doesn't work like that. So it's one global thing, probably installed by the cluster admin, and then everything else goes through specific team namespaces or app namespaces. So what we did was to allow, we changed the dependency declaration, and now is a namespace reference. What that means, when you declare a dependency, by default, you can specify its name, and the controllers will search for that particular dependency in the same namespace. But you can also add a namespace to the dependency. So I can say dependency name Istio namespace Istio system, and then you have this cross namespace dependency feature. And Yeah, because we built first the customized controller and customization, and we've implemented dependencies there. Afterwards, when we got dependencies into Helm controller, people said to us, "Hey, what about multiple namespaces?" And yeah, you are definitely right. We should have thought about that at the beginning. We didn't. We made the breaking change, and that will be part of the 0.1 release. There are other changes here. One problem with the customized controller around garbage collection. So how garbage collection worked, it labeled all the things that got reconciled on the cluster using the revision from Git. So the Git branch and the Git SHA. The problem with this is that you'll get a bunch of alerts, a bunch of notifications every time you change something in your Git repo, even if that change is not in any way related to the manifests. Let's say you change something in your source code, you don't touch the manifest, but because all the objects are labeled with the Git SHA, we change the label, and Kubernetes API will say, hey, all these objects have been changed. And indeed they have, because we've relabeled them. So in order to trim down the alerts and not have to deal with this kind of verbosity, we are now creating a checksum out of the manifests that are applied on the cluster, and we relabel them only when that checksum changes. What that means is that starting with 0.1, you'll get a notification only when you change your manifest and not some unrelated file in your repo. And for that, the status sub-resource of the customization API has to be changed in a way that doesn't make it compatible with the old version. Other things that are not breaking changes are features. We've added S3 bucket support to the toolkit. So instead of reconciling manifests from a Git repository or from a Helm chart, now you can reconcile things that are stored in a bucket. And it's not just Amazon S3. You can use Minio and Google Cloud Bucket, any type of service that is compatible with the S3 API.
Hey, Stefan, can I ask you a question real quick?
Sure.
It's Stacy. So Mahmoud and Steve were on the call, but apparently, I think, guys, feel free to jump in here, but they only had a few more minutes left, and I believe they wanted to talk about a few things before they had to bounce. Is that okay to do now?
Sure, let's do now.
Okay.
Hey guys, hey Stefan. Thank you for the update. I just had a question about a few things. So first is the Helm operator. You said it reconciles the resource, the Helm controller reconciles the resources. Is it already doing that for the Leaf objects or just for the Helm release object?
For the Helm release object.
Okay, got it. And my other question was, you mentioned 0.1 release. I see that most of the issues are addressed. Do we have even a rough estimate on when that would be?
Yeah, I will get to that after I'll finish the list.
Thanks. Steve, did you have any questions?
Yeah, it would help if I wasn't sat here on mute. Hey guys. I think, Mahmoud, you asked the main question that I had, which was kind of the release date. And I know the two of us and Stacey have kind of been talking about a natural migration path and where that is in the roadmap and what version that's going to be kind of cut from. I assume that's going to be a V1 rather than a V0 dot something.
Migration from
existing.
Or
from existing Flux setup to new toolkit.
So we have a roadmap document that you should look at. In order to get full feature parity with the current Flux, we still have to implement the image update feature, which is at 0% right now. So we cannot give you an estimate when that will be done. Probably by the end of the year, but who knows? As for Helm operator, Helm controller, the feature parity is at 100%. So if you are just using Flux to synchronize namespaces and Helm release YAMLs, then you could definitely migrate to the toolkit. But yeah, image update feature is far, far away.
Beyond just the technical feature parity as well, we will be creating documents for the various types of installations and how to migrate. How much of that will be tool assisted is unknown, but at a minimum, we will have documentation about what to do.
Yeah, so for the users of flux.yaml, there will be no automation in place. We'll have a extensive guide of how you can migrate, mainly because FluxYAML right now allows you to do whatever. You can run bash scripts, you can run whatever you want, and we're not going forward with that idea. So you'll have to move all the custom things that you are currently doing in FluxYAML into your CI pipeline. From there, write to a branch or a bucket or a Helm repository, the final result. And from there, sync that on the cluster with a customization object or with a Helm release object. And yeah, trying to automate that doesn't make sense to me. Going from a classic Flux installation to a toolkit installation is also a tricky thing. Like, for example, when you install Flux today with FluxCTL, there is no self-upgrading feature in there. The only tool that does that is EKS-Kato. But FluxCTL itself, it just writes some YAML, you install Flux on the cluster from some YAMLs generated by the CLI or generated by, let's say, Helm, if you use the Helm chart. With the toolkit, we took a different approach where by default, when you install the toolkit is able to update itself and provisions itself in a repo, and you can also create the repo, the deploy key, and all that with a single command. So here are also big differences. If you want to keep the current way of deploying Flux, where you deploy it by applying some YAMLs, we have that in the toolkit is GOTK install -- export that generates YAML in the standard out. Then you can do kubectl apply of those. So that's similar to FluxCTL install pipe kubectl apply. So for that particular use case, yes, you can say we have an identical command that you can run. But for all the other use cases, there will be guides, documentation on how you can migrate. And we haven't. So going back a little to the 0.1 preparation, we have here a section around multi-tenancy. What we are trying to do is we are trying to come up with a solution that is very similar to the multi-tenancy solution that we have in the Flux repo, where you install one Flux per namespace and so on. So we want to take that use case and make it work with the toolkit without installing a bunch of controllers per namespace. So it will be a single set of controllers running, then the controllers will do impersonation of each of your tenant based on the namespace where they're deploying things. But the end goal here is to be able to migrate those that are using the current Flux multi-tenancy approach to the new toolkit multi-tenancy, and achieve the same thing, like limiting each tenant access on the cluster, but without installing the toolkit on each namespace, just creating.
Yeah.
Yeah.
And one important distinction is it's actually more precisely not based on where they are deploying things, but more specifically where they are reconciling from is what it's based off of.
Yeah.
So I've just Stefan and I have put in a lot of time, both publicly and privately, on design for this, and we think we have something that will work very well for the default installation. Ideally, this is as easy to use as possible, but still encourages people to do things correctly. We would really love input on this. Stefan's posted some initial public documentation about how this is supposed to work, and as everything should be. And so the idea is that we want to allow like namespace level control for admins to restrict permissions. The normal way to do this is RBAC, but this is challenging because we have the one controller doing an apply for a particular resource like customizations or Helm release. And that lives, in a privileged namespace typically for our default install. So if that controller has a service account that lets it impersonate other users, we considered just impersonating service accounts. The issue with impersonating service accounts is that they don't have to exist, is what we found out. But if they do exist, then this is an identity that can be assumed by a compute workload in the cluster, and that's not necessary. We plan to continue supporting service accounts if this is already something that people are doing, is using service accounts to supply tenants access. But the more ideal mechanism, somebody's echoing, the more ideal mechanism is that we just use a namespace username. This is similar to what Kubernetes is doing for service accounts underneath the hood. If we create a GOTK system style namespace, and then we make sure that any of the users that we're reconciling are bound to the namespace that owns the reconciler definition, then we can be safe. And so the username will be GOTK, and then the namespace of your reconciling resource, and then the user that's specific for that thing, so that you can have multiple users in a specific namespace. And that username is defined by the customization or the Helm release. So you would say Helm release, my reconciling user is, app team GitOps reconciler, and then you would be able to write role bindings against that in any namespace, which is a little bit of a confusing detail about how RBAC works. Is if you want to deploy to a namespace, it's the namespace RBAC administrator's decision on who or what users are allowed to deploy to that namespace. So the app can be deployed to a different namespace than the customization's actual namespace. You do that with the role binding. We'll have more examples of this, but does anyone have any immediate concerns or questions?
I didn't quite catch what the advantage of using users over service accounts was. Is it mainly a semantic thing, like service accounts are for running workloads, users are for having?
No. Yeah, also that, but that's not a concern I had. The main problem is that if you apply a pod definition, then you can tell that pod to run under the same service account that was applying it. I need to let you do that because it's the same service account. Now, if we impersonate users and add service accounts, then you cannot just create pods that are running under a user because Kubernetes does not support it. So in a way, you could, even if as a normal user, you could create a pod that runs under the same service account that's a reconciler, because that's one of the things that Kubernetes service accounts are meant for, while users are not. So deciding by default to create users and impersonate users does not allow anyone to create a pod that could take that identity.
Okay, so it's shutting a possible privilege escalation hole.
Yeah.
Yes, this privilege escalation would be if the reconciler has permission to create pods and the repository, and in the same namespace that the reconciler definition lives, basically. Because the service account or user will always be namespaced to the same namespace as the reconciler definition, which would be like a customization for a Helm release. If you're deploying to it, yeah. Mm-hmm.
The attack service is very limited, because in order to actually get the pod running under, let's say, cluster admin, it needs to be a customization that has been deployed in the GitOps system. And that's only cluster admins can do it. But still, we shouldn't be allowing this kind of stuff, because you cannot control the Git repo. Maybe, you don't do a good pull request review and you get a pod with cluster admin in there. Using users, we don't have that issue. So that's why
sounds like the sort of thing that if you left some fields out, you might unwittingly give your users the ability to escalate them. So safety by default, security by default.
Yeah, and going back to what Lee described, the idea in the end is very simple. If we think about how the Flux multi-tenancy repo is built today, the idea is when you deploy a Helm release inside the namespace, so you create that object, then Helm controller will impersonate a user inside that namespace that restricts whatever is in the Helm chart to be able to mutate things only in that namespace. So the idea is very simple. If you as a team, as a tenant, own a namespace, you can create a Helm release there, but every single object in that Helm chart has to change things or delete or whatever it does only in that particular namespace. So,
or any namespace that finds access.
Okay, you can, as a cluster admin, you can extend the access of a particular team to more than one namespace. But by default, without doing any custom RBAC, just running GOTK create tenant, that command creates a namespace definition and a role binding for that namespace only. So running that command, it gives you these two objects that are enough to do what the Flux multi-tenancy does today, and a lot of people are using that. So we want to make it very easy for people to migrate to that particular solution to the toolkit. And we'll have some CLI commands that let you bootstrap the namespaces and your tenants very, very easy. And afterwards, of course, we give you the freedom that wasn't possible with the multi-tenancy Flux approach, give you the freedom to extend a team's reach more than just one namespace. You can give it more namespaces, or you can give it access, write access to particular cluster-wide objects. Let's say you have a team, let's call it the networking team, and the networking team should be in charge of defining, let's say, network policies and other things like service mesh objects itself. So, for example, in NavMesh, the mesh object is cluster-wide. So maybe a team, you should give that right to a particular team to be able to do mesh actions. You can extend the current user, you can create a cluster role binding, add the subject to that particular user, and give it access to only the mesh object. So they will still not be able to create other cluster role bindings and taking control of the whole cluster, but they will be able to do their job, like create networking objects and so on. So that's the idea around multi-tenancy, and we are We are currently in design phase, so that's why I cannot actually say that we're going to release 0.1 next week. We hope is by the end of next week, but yeah, during testing maybe something will break and we'll not be able to release it. So
I have a question here. Is it safe to or do you guys recommend that we don't do any public presentations of sorts until 0.1 is out, or is that even should we even wait further till 0.2, for example?
No, I think after 0.1 we can do public demonstration. There is one blocker though, what Michael mentioned in the issue, that we have to define what Flux version 2 and Helm operator version 2 is. Is it just a GOTK install command with a particular set of controllers? Is it more than that? So we have to, come to a decision, write the definition for these two components, and afterwards use 0.1 to showcase how Flux v1 read-only users and current Helm operator users can migrate to the new thing.
Thank you so much, guys. I have to drop, but thank you guys so much.
Bye. Oh, so two more things that will be included in the 0.1 release. For those that are running clusters at home on Raspberry Pis, the toolkit will be working with ARM v7, so you don't have to use ARM 64. It works fine with v7. Alex Ellis from the OpenFast project tested out, and it works great on Raspberry Pis. And there was another change. 1 second. Oh yes, we want to extend the Helm release documentation. So the current Helm operator has extensive docs around how you do rollbacks, how you do all sorts of things. We have feature parity in terms of the API, but we don't have feature parity in terms of the documentation, and we want to get that out. So people know, okay, if I have a Helm release v1, how do I migrate to v2? How these things match and what I'm achieving. The behavior changed for some of those fields are shifted around. So we'll have extensive documentation on how you can get on the v2 Helm release. And that was it, kind of a long overview. Any questions?
Well, how about we open the floor? So any questions on all the stuff Stefan was talking about in the release? Or is there anything else people want to table to talk about?
Jonathan, were you going to ask some questions?
Yeah, we were, I know, Stefan, you mentioned that for GoTK, you have a -- export option to kubectl apply the manifests like on your own. We were curious if y'all were eventually going to support Helm charts as well as a way to apply the raw YAMLs.
So the only way we can make the toolkit installable with Helm is by placing the CLI in a pod, deploy the pod with Helm, run Helm install -- export kubectl apply from that pod. Helm is not made for deploying operators. It cannot upgrade CRDs. And as you can see, we change CRDs all the time, and we'll be doing that for a long time now, and so we cannot just create a Helm chart that will break the second we upgrade a CRD. So no, we are not going to support the Helm chart anytime soon, unless someone wants to do the pod kubectl apply hack just to have a Helm chart. I don't know if it makes sense. What do you think, Scott?
Can you hear me okay, by the way?
Yeah.
Okay. I was told my mic was muffled earlier, so I've changed it. I'm glad it works better now. Yeah, so this is something I've been thinking about quite a bit, is, you know, whether or not really we want to better define some of the earlier discussions about Helm and CRD management. At this point, Stefan is right. At this point, there are less than zero plans to support any additional CRD behavior for Helm. But I've been thinking through it a lot more and talking with some folks on the Flux team as well about what possibilities there might be for at least better management. Sorry, let me be more clear. At least the upgrade scenario, not managing by changing CRDs in any way, but potentially handling an upgrade scenario. And the answer is that's just still in discussion. So I think you're right, Stefan, that you wouldn't want, like, Helm is just not really suitable for that at the moment. However, I think there's room for us to think together about how other tools, you know, for example, I think you're using Customize now, right, to handle CRD upgrades, how that might be a good pairing with Helm releases. And I'm only saying that because, you know, Stefan, we had already discussed the possibility of including some customized functionality within the Helm controller in order to support certain features that are new in versions of Helm 3, such as the post renderer. You know, so that there might be some possibilities to discuss there. It's in the sketch phase.
Yeah, that's okay. That's a feature in the toolkit. But the question was, can you install the toolkit with a Helm chart? The answer is no, because at the first upgrade, it will be broken.
Oh, I see what you mean. Using Helm I may have missed the context there. So using Helm to actually install GOTK. Yes, I agree with you. The answer is no, at least for now.
Yeah, I mean, if anyone needs it for some reason, maybe you cannot deploy anything but Helm charts on your cluster, then we can do a trick with having a pod running at cluster admin and just do kubectl apply of the GOTK install standard output. Would that work for you, Jonathan?
I think the issue for us was more that the manifests are being reached out to an external point through GoTK install, and that we would need to possibly be doing some custom things with some of the controllers, as well as be having internal endpoints that we reach out to for the manifests. So yeah, so it would be difficult for us to keep up with releases if there isn't some sort of versioning system with those manifests, I believe.
What do you mean?
Because we would have to continue to pull, I guess, those manifests every time they get updated, in the sense of like y'all are going to be doing updates, and we have to make sure that we continue to get those updates on our end, and we would probably be having to apply raw YAML because we have to store those at some place on our internal endpoints.
Okay, so let me explain a little how GOTK works. We do Semver releases. We do GitHub releases. The YAMLs are attached to each GitHub release. And when you do GOTK install for a particular version, what it does, it calls GitHub, downloads the manifest for that particular Semver release, customize them in in a specific way. I don't know, if you want ARM, it will replace, it will say, okay, now we're using the ARM 64 repository. If you change the namespace, it will patch the namespace. It creates a bunch of things there, and then it applies it. But the manifests are semvert. So if you download the manifest.tar from GitHub releases, and you apply that on the cluster, it should work. Are you saying that your cluster is not able to access GitHub, and that's the issue? You have to mirror GitHub inside?
Yes, that's correct. Yes.
Okay.
So is it kind of a situation that you have to stage stuff somewhere?
Yes, essentially, yes. We have some internal point where we would have to essentially mirror that versioning on our end. Yes.
What about?
Are you able to mirror a repo?
I believe we could. I believe we could be able to do this. Yeah, I think we could probably actually mirror. Now that I understand.
How do you manage Helm chart mirrors?
Let me think. We essentially do the same thing. I believe we could make this work. Yeah. I think the issue. I guess we can do the customization on our own. Yeah, I believe that makes sense. Yeah, I think I understand a little bit better. I think we can do this. Yeah.
So if you do git clone toolkit repo, then git checkout v0028, then you do customize build manifests /install that, and you pipe it to kubectl apply. That's what GOTK install does. So if you are able to maintain a clone of the repo inside your own infrastructure, then you can do the same thing with no releases, no nothing. You just check out a particular release from the branch and you get those identical manifests.
Okay, sounds good. That makes sense. Yeah.
Okay, if you get stuck on this, I don't know, can reach me on GitHub or Slack, can help out.
If there's a better way that we can document this as well, as an alternative installation, and, if you have ideas or want to contribute, that could be valuable.
Something we found with Flux was that once you have a chart and you have another means of installing it, and people can just get the stuff from GitHub, that's three things you have to kind of keep in parity, and that starts to get very painful and onerous. So the fewer ways of installing it, the better, really, as far as I'm concerned.
Yeah, I mean, it's great that we have the CLI, but I think for the install, I know that this is a pattern that we've essentially copied from other people. I do question what value it adds, when we're just using customizing the hood. But
well, it does a bunch of stuff other than get the manifests, I think is the answer.
Yeah, we're indirecting and patching things with different values, which is not something that Customize does well. So
yeah, so the main difference is that the manifest /install customization uses the GitOps system namespace. It's in there, you cannot change it. Now, with the CLI, you can say install -- namespace, whatever, and it will patch cluster role bindings, service accounts, roles, whatever. When you change the architecture from MD64 to something else, then it changes, for example, the node affinities for the controllers. It changes the container registries for all the controllers and so on. So it does some transformation using Customize as a library. So that is not in the manifest themselves, is in Go code with Customize.
Right.
But
hilariously, you have to sort of create an API so that you can change the customization, because you can't do that just with the customization.
Well, we could just, yeah, as soon as you have multiple permutations of on several axes, then now you would be maintaining 9 copies of the customized variations, with one base in your repo. Like, so that can get tough.
It's
but
not.
But that's how you would do it with customizes. You would have variations for all of your install paths. So
Yeah, but it's also things like if you have to change one value but in multiple places, then when you use that, you have to know which places to change.
Yeah, we also do that in the CLI. Yeah. What we can do is write a nice doc on how you can create your own overlays and like a deep dive into customize things, how you can achieve the same type of customization on your own just by using the manifests from the repo as a base customization and do all those things. If you don't want to use the CLI, there is also a discussion started by someone and said, "Oh, what is this CLI magic? We want everything declarative." And if you look at that discussion, I replied there how you can install and manage the toolkit without the CLI at all. And you can see it gets, there are a lot of things you have to do. Like the CLI is just one command and it works. But I'm definitely not for having only the CLI is the only way to install it. We should document how you can further customize everything with just customize and plain manifests or yeah, no Helm charts.
Makes sense, yeah. We also had a follow-up question about the discussion we had last week, Stefan, with GoGit and V2 for Git in terms of just, I guess, determining why GoGit was chosen for the package support when it doesn't support Git V2, and just kind of moving forward how we plan to support that with Azure DevOps. Just continue that discussion as well.
Yeah, so my understanding is that Azure DevOps currently deploys a Git server next to Flux, because then thousands of clusters will hit the same Git endpoint on the Azure DevOps side. So in order to avoid that, you run a Git server locally on each cluster. And someone from your team proposed that can we use something like Azure Bucket or Azure Files or whatever instead of hitting the Git repo back? What we did, we've implemented an S3 compatible bucket as a source. So let's say if Azure Bucket talks S3 API, then from an Azure DevOps workflow, when someone commits to a repo, you can take a repo clone, push it to the local bucket on the region where that AKS cluster is running, and the toolkit will reconcile with the bucket instead of reconciling with Azure DevOps Git, and that will completely avoid connecting to the Azure DevOps Git at all. So, is that feasible or no?
Yeah, that makes sense.
Now, after implementing the S3 thing, I was looking at Azure Bucket, and I couldn't find anywhere in the docs if it's compatible with S3 or not. So if it isn't, then please add support for Azure Bucket to our current implementation.
The Minio library, Stefan, that we're using.
Yeah, we are using the Minio library, which is compatible with any kind of service. I don't know, Alibaba Bucket, whatever bucket. Every single cloud out there has a bucket offering, and I guess all of them except Azure implemented S3 compatibility. I couldn't find anywhere in the doc, so I'm assuming Azure doesn't talk S3. So if it doesn't, then I'm guessing Azure has some kind of Go library that is able to talk with Azure Bucket API and fetch the files from there.
I can look into that. I think that the Azure Bucket, I'm using Azure Bucket, and I don't know that much about it, but I think that it is S3 compatible. But I can look into that and report back if no one else is in their way.
If it is why is not in the docs, I have a feeling like Git version 1, maybe it doesn't fully implement S3 and some things couldn't work. I don't know.
So
stuff.
Yeah, I actually don't have anything against running a separate Git server that you proxy through, because that's actually what we're kind of doing today with Flux and Azure DevOps, because of the way Azure DevOps works with SSH keys and programmatic users. We've actually built a small proxy where we basically, because you run like a multi-tenancy setup, we have one personal access token that we give to our proxy, and then we give local keys that are namespace specific to each Flux instance, and then all traffic goes through that, and then we just inject in the personal access token based on the namespace or the repository that you're trying to access. So for me, as long as we document it and describe, okay, if you're running Azure DevOps, you need to do these types of things and run this Git server here as a sidecar or whatever to get it working, I think I would be fine with that at least.
Going back to one of the original questions, is that how did we choose Go Git, knowing that it didn't support Git v2? I don't think that we knew that Git v2 was a thing, and that Go Git did not support Git v2, and that Azure DevOps only supports Git v2. So this is not like a premeditated thing. It's just an unfortunate consequence of choosing the dependency. I did look into whether or not there were other Go style Git dependencies that we could use, and the answer doesn't seem to be yes.
No, it's the only maintained library.
Yeah, and then
there are several advantages to it. They have managed to get the full Git file system into memory. You can do unit testing with it in a very nice way. You can do a bunch of stuff, and the whole source control API is based on Go Git futures. We are not going to switch it anytime soon.
Yeah, I mean, Git itself is well tested, but it would be we would be doing when you exec the Git CLI, there's a whole subsection of subs commands that are, or there's a whole series of sub commands that are intended to be machine used. So they output very simple things to standard out based off of exactly what you're trying to do. Obviously, the Git project is incredibly well tested. And then if there's a desire to get a repo in memory, it's very easy to get a tempfs. So some of these advantages are really just interface differences. Obviously, there's a huge, I think the huge benefit is that when you have the Git library native to Go, you can take advantage of Go scheduling, and probably the biggest difference for our project is going to be the types. Because when you exec the Git commands, you would need to wrap what types you're expecting in a parser, and there would be parsing going on. So that's probably the big difference. The other stuff is just mechanical, and all of that can be done with the proper interfaces. I don't see in-memory being a big difference since tempfs are easily available, and I don't see testing as a big difference because, one, we're relying on a smaller project, whereas when you actually rely on Git and use the machine readable interfaces, that's already completely solid. So.
No, I'm talking about our testing.
I see. Yeah, I mean, we would use the machine readable, Git commands and test against that. I guess the big thing there would be the types and tests. If we're using,
for example, Flux has to run as root because we have to get the PGP keys from the PGP service. GoGit has PGP in-memory storage. You don't have to do any of that. You don't have to have PGP installed on your in your cluster. You don't have to touch the disk in any way. You just take the keys from the secret. It's a byte array. You feed that byte array to go Git, and it works. Like, yeah, going back to Git, I don't think it's an option. Any other things, Jonathan?
No, that's it for me. Thanks.
Cool. Have you tried it out? How did it felt?
I think it works really well. I think the separation that y'all have now with the different controllers is really good. There's a lot of architectural changes that are really good, I think.
Great. Yeah. Okay. Let us know if you have any issues going forward. We are happy to answer and find ways to make it work on Azure DevOps.
I have a quick thing just to make sure. The issue I created regarding Helm status and the readiness checks and everything around that was not working as I expected, at least. Did we agree that the solution for that was to document that basically if you're running a Helm chart with a single replica of a deployment, you should probably use some sort of pod reception budget? Or what was?
So I think we can make two things in the docs. Recommend people to use Helm tests and not rely on the I don't know, custom status thingy that Helm does, and clearly it doesn't do it like Kubernetes does it, because it cannot detect failure if you have a single replica, which is mind-blowing. I don't know what's going on there. So I think we should recommend people, hey, enable tests in your chart, write tests, so you get more than just, the pod is running. But if you don't have tests, then you cannot rely on the, I don't know, Helm built-in check, because it's buggy. So you have to run at least 2 replicas of your app, which I don't know if it works for everybody. Maybe not. Maybe there are like legacy services that cannot be run as 2 replicas. So that's not a good solution for them. But yes, we should definitely document that. And yeah, I forgot about that issue. Thank you for bringing it up.
Yeah, I think I was supposed to write the docs, but I also forgot, and I just realized now that looking through my backlog of issues that, oh yeah, that was there. But I'll try to write something up. But I have the GitLab or the Git notification documentation I have to get done before that. So
yeah, thank you very much for getting that in.
Yep.
Is this Helm status bug new with Helm 3?
I think it's been there.
No, that's always been there. There's a PR open for it.
Oh, I've never run into this bug before, and I've deployed a lot of charts with 1 replica. Yeah.
Was that Scott?
I was just going to ask for someone to pass me that way, the issue my way that Hida just did in the chat. So I think this is it, right, Hida? Yeah, I got it.
That's it.
Thank you.
Yeah, Sean wrote it. It should fix the issue.
Yeah, this is not on my radar yet, so thank you. I'll look into it.
Yeah, so until this gets fixed, if it gets fixed, switching to K status from what Helm is doing, I don't think it's an easy change for Helm. But until there is a fix or something else, we should definitely create some docs around it, because yeah, it can be very surprising that Helm wait says, yeah, everything is running and your pod is in a crash loop.
Yeah, great.
Any other last questions?
Have to be a very, very quick one.
1 more minute.
Okay. It'll have to wait for next time.
Yeah. Thank you very much, folks, for attending. Do we announce what those that are meetings every week now, Michael, or
Not here we haven't, but on the list and so on we have.
Calendar invite went out. Anyone who, that's how I found out.
Yeah.
It is in the meeting agenda as well.
Cool.
Yeah,
the time, I think, might be changing, and there is now one in a different time zone every other week.
Yeah. So we try to accommodate both time zones, EU and US, and we'll be doing this meeting every week now, not every 2 weeks. So hopefully
time zones alternate.
Yeah. Okay, that was it. Have a nice evening, day. Bye.
Yeah.
Bye.
Bye, everyone.
Bye.